we want to add 2/5 to 3/4. Least common denominator, 5 times 4, 20. In this case, it's 20. Multiply by 1 in the form of 4/4. Multiply by 1 in the form of 5/5. The denominator is 20. The denominator is 20. Numerator 8. Numerator 15. Add the 2. You get 8/20 plus 15/20, which is 23/20, which you could have written as 1 and 3/20. No need to do that. Okay? If you start with mixed numbers, then put your answer in the form of a mixed number. Example 2. You want a common denominator b and d, multiplied by 1 in the form of b over b, by 1 in, no, this d over d, this one b over b, d over d, b over b, same denominator bd. Numerator AD, numerator BC, so AD plus BC is AD plus BC over BD. Okay, example 3. We could have used, we add 2/15 to 3/20. We could have multiplied by 1 in the form of 20/20. I say we could have, okay? Relax, I know you may know better. We could have multiplied by 15/15, which is 1. We get the same denominator of 300. Numerator 40, numerator 45. Sum 85/300. You can factor out a 5, that's a 1, 5/5, and you're left with 17/60. The object of the development above is to show the importance of the common denominator. The development below will use the least common denominator, which is 60. You used 300, which was okay, but it was bigger than it needed to be. 60 would have been sufficient. I do a prime factorization of 15, a prime factorization of 20. I put as many of these numbers in the same column that I can, like these two 5s. I do not mix different numbers, different factors in the same column. Least common denominator, the product of all the numbers in the columns, one number per column. So 10 times 6 is 60. So, in 20, let's come back over here. What do I multiply 20 by to get 60? What is missing? The 3. What do I multiply 15 by? What is missing? The 2 times 2, so 4. So multiply by 4/4, by 3/3, you get 8/60 plus 9/60, which is 17/60, which is identical to what we arrived at before with the big numbers, with the denominator 300. Note here that x minus 2 and 2 minus x are exactly opposite. If you multiply by 1 in the form of -1 over -1 and distribute the -1 in the denominator, you'll be left with the -1 in the numerator, but the denominator will become x minus 2. Okay? So, if you didn't do what I just told you, if you said the common denominator is x minus 2 times 2 minus x, you get the following. And okay, I could have done it that way, but apparently I changed my mind. So forget about this and forget about that. I'm back over here. Now, forget about this line. Skip from here to here. You get 8 minus 4x. You get 2x squared minus 4x over the common denominator x minus 2, 2 minus x. And combine like terms, that gives you 2x squared minus 8x plus 8. Factor out the 2. This is a perfect square, namely x minus 2 squared. Divide by x minus 2 over x minus 2, which is 1. You're left with 2x minus 2 over 2 minus x. Or when you factor out the -1 from 2 minus x, you get the opposite of 2 over -1, because all this becomes 1. X minus 2 over x minus 2, your answer is -2. That was the hard way of doing it. The easy way, factor out a -1. So the opposite of the quantity x minus 2 is -x plus 2. negative x plus 2. The negative sign could be in the denominator, in the numerator, or in front of the fraction. Note that you have the same denominator now. You get 4 minus 2x. You factor out a 2. 2 minus x over x minus 2. Factor out the negative 1 again. You get x minus 2 over x minus 2, which is 1. And 2 times negative 1 is negative 2. Same result we had before, but easier to do. Example 5. We need to factor the denominators. First denominator x plus 5x minus 2. Second denominator, I use a product sum. 2x minus 3, x minus 2. Third denominator, greatest common factor is 1. So product sum, magic numbers negative 3, positive 10. And 2x minus 3 times 2x plus 5. And then we want to put these together in a column to find the least common denominator. This is like a prime factorization. X plus 5 in this column, x minus 2 in that column, 2x minus 3 under 2x minus 3. Take these factors one per column, so you get x plus 5 times x minus 2 times 2x minus 3. Okay, least common denominator. What do I have to multiply this by to get the least common denominator? What is missing? 2x minus 3. This one, what is missing? X plus 5. This one, what is missing? X minus 2. So, denominator 1, denominator 2, denominator 3. You need to multiply by 2x minus 3 over 2x minus 3. You need to multiply by x plus 5 over x plus 5. And you need to multiply by x minus 2 over x minus 2 to get the same common denominator. And your numerators are now 4x squared minus 6x, 4x squared plus 20x, and you subtract the entire numerator. Be careful. You subtract the entire numerator. You subtract 8x, and you subtract negative 16x. That means it becomes, oh, that's a misprint. That is supposed to be plus 16x. Oh, that's too bad. Okay, so I get negative 4x squared. If this is right, negative 4x squared. 4x squared minus 6, 4x squared plus 20x minus 8x plus 16x. So the x squares, they drop out. 4 plus 4, 8 minus 8x squared. The x's, 20 plus 16, 36. That should be 30x, not 2x, 30x. Well. So there's a misprint here. This is not correct. In example 6, this is a difference of two squares. This can be factored as x plus 5 times x minus 5. So, okay, I reproduce that here. And I need to multiply this by x plus 5 over x plus 5, this by x minus 5 over x minus 5, distribute, and again subtract the entire numerator, which means I was careful here. I subtracted x squared and I added 5x. So I have x squared plus 5x, minus x squared plus 5x. Okay, here I was careful. And that is supposed to give you, the x squares drop out, the 10x, 11x, 11x over x plus 5 times x minus 5. Okay, exercises for chapter 48.